And we're taking the quiz. We can hear you now, Ben.
Shh, there's a test going on. You need to keep your voice down. The quiz, you should. Oh.
Done? Everybody done? Yep. Hundreds? All right, Ben, are you done?
Yeah, I'm done.
You already submitted it?
Not yet. I'll probably submit it after the class.
All right, I won't call up the answers then. All right, homework, get it out.
Oh, yeah, homework. We only have to turn around down the triangle. We only have to turn around down the triangle.
Oh, yeah, that's right. I forgot. This was from last year. And since you already knew all the answers, then obviously I don't need to go over it. All right. Career day tomorrow. So we're going to do normal assembly. Then we'll do periods 1, 2, 3, 4. There'll be a guest speaker in each one. Period 5, you're going to do 10th grade against 9th grade volleyball game. Then eat lunch. And then period 6 and 7 will be the college counselor just talking in general terms about what high school looks like in preparation for going to college. What do you need to do freshman year, sophomore, so forth, and all. Just to give you visibility on that stuff. All right, homework. We actually have 6 theorems today. It's lots. What is this a disturbing thing that you drew, McKinley?
I have no clue.
It looks like someone in their underwear who has I don't even know what that is.
It's a mouth.
What?
Probably. It's tentacles with a mouth.
Okay. Why is the octopus wearing underwear?
It's not underwear, it's his torso.
Underwear, me.
Obviously.
Underwear. Underwear. Underwear.
That's not underwear.
Okay.
We have a lot of theorems in this chapter.
Yeah, the quadrilateral polygons, lots. There's not a single one of these that is difficult to understand. One of them is a little slightly challenging to prove, but they're all easy to understand. All right, ready? All right, I don't know why every single math book's called them special quadrilaterals. Well, why are they special? I don't know. They never explain that part. They just call them special quadrilaterals. There's nothing special that differentiate them from a parallelogram, right? They're just a different quadrilateral. Why do these get called special and the other ones don't, right? We're going to get something called special right triangles, and I'll tell you why they're special, but there's nothing really special about these quadrilaterals in the sense of these are the good ones, these are the bad ones, that sort of thing, nothing special. All right, so tough day, right? Tougher than this guy, or maybe not as tough as that guy.
What happened?
What does it look like?
Oh, cactus.
Yeah.
It looks like a fur coat. These
Exactly.
Like
That guy's in trouble. He's playing golf. His golf club's right here. So apparently he fell into the something, but he's covered in cacti.
Well, how is that? I mean, it would hurt, but it's not like an emergency.
That's why he's standing around and the paramedics aren't like jumping around and doing resuscitation or something like that. They're probably just trying not to laugh at the guy. There's a classic video on you. I'll let you watch it yourself of a guy jumping off of a car into a cactus.
They're probably trying to figure out how he.
Yeah, probably. All right. Yeah, I gotta hand these out. Where would they be if I were
We haven't
handouts?
had a lot of worksheets.
What? You haven't had a lot of worksheets?
No,
Yeah,
don't
that's
do
true.
as much.
That's true. All right. So I'm gonna let you figure out what you need to put in your book of truth and what you don't need to put in your book of truth. This is a
Rectangle.
what makes a rectangle a rectangle.
For writing.
Okay, that's what a rectangle is. So if you already know that, then clearly you don't need to have it in your book of truth. But if you want to, I'm not going to give you give me the definition of a rectangle ever, but I'll say it's a rectangle, and then you may have to do something with it. What differentiates a rectangle from a quadrilateral is that it has 4 right angles. Let's say anything other than that.
But can't the top equal what, 180?
What do you mean the top?
Like, let's say this side wouldn't equal 180 since it's a parallelogram, or wait,
Is it a parallelogram?
yes,
Why is it a parallelogram?
because well,
Opposite angles.
yeah.
Okay, so you just proved that it's a parallelogram. Boom, look at that. All rectangles are parallelograms, and you proved it by 5, 6, which says opposite angle. You could have done it by consecutive angles or supplementary. Either one of those would have proved it. So when it says that the consequence that all rectangles are parallelogram, guess what that also means for rectangles?
That all parallelograms are not rectangles.
Okay, that too. I was thinking more, what does it tell us about rectangles then?
That all the sides are congruent.
No.
Opposite sides are congruent.
Opposite sides are congruent.
Diagonals bisect each other.
Diagonals bisect each other. Anything
All
else?
sides are still congruent because they're all
Not all sides, opposite
Oh,
sides.
wait, no, but still all sides. It's 90, 90, 90.
You're talking angles, we're talking sides.
Oh, sides. Angles.
All the angles are congruent, true, but that's not true for parallelograms. we only say that opposite angles are congruent and consecutive angles are supplementary. One you left off, and it's the definition of parallelogram.
What?
What's the definition of parallelogram?
Parallel sides.
Yeah, opposite sides are parallel. So those 5 things we can now say about a rectangle. Okay, next special quadrilateral is called a.
Rhombus.
So what makes a rhombus a rhombus?
All sides are congruent. All sides.
That's it. All sides are congruent. It's quadrilateral where all sides are congruent. Notice it doesn't say anything other than that.
Well, how do we prove?
No, that's a definition. That's not a prove. That's a definition.
But can I prove it's a parallelogram? Because it looks like it could be one.
Well, we're going to prove that.
Well, you could do the same as 5, 6. I mean, 5, 6.
So what are you saying the shape is?
Opposite sides are congruent.
So therefore it is a.
Parallelogram.
So consequences is rhombi, plural. Rhombi are parallelograms. Therefore we get those 5 things. Opposite sides, opposite angles, consecutive angles, opposite sides are parallel, and which one did I forget? Opposite angles are congruent.
But isn't that only for this one? Because I don't have to put the tick marks on.
Well, just remember that we just proved that a rhombus is a parallelogram. So you're given these red tick marks by the definition. All 4 sides are the same. The rest of that stuff we get because it's a parallelogram. And what Jack said, we're actually going to prove today, although we did prove it yesterday. Oh, Ben, you never explained why yesterday you never complained that the screen was black the entire time.
Maybe it's because he's away.
Exactly. It's now been proven.
I think he's away right
He's eating donuts right now.
I think he just
He
watches
probably
the
just has a
video.
recording or something.
He probably just watches the recording. Yeah. And then,
Then
he,
why
like,
does
goes
he
to the
even go
guy.
Yeah,
on
but occasionally he gives us responses.
Yeah. If he just watched the recording,
Ben,
why would he even
What is
log
your
on?
middle name?
I don't know, and I don't really want to tell you. I do know. And I said I don't know. No.
So why didn't you complain yesterday that the screen was black?
I don't know. I didn't really care. I was like, oh, I already knew all this. I'm sure it's fine with the actual recording. I looked later. It was not.
It was not. I had to give you the recording from the non-honors class because the screen was black the whole time. I forgot to take it off of not mute audio, but mute the video. Is that a word? Mute the video? No, it's not a word. Okay. So rhombi are parallelograms. We get those 5 things. All right. Next one. That's
Same
a.
exact one as before. They're all angles are 90 degrees and all sides are congruent.
So most math books tend to. We could call this a rhombus where all angles are 90. Or, no, most math books don't say that. They say a square is a.
Rectangles are all sides are congruent.
Yeah, and that's what they choose. But we could have chosen that it's a rhombus with 4 congruent angles, or 4 right angles, either one. But they choose a rectangle, so it works that way as well too.
But why? But a rhombus doesn't look anything like this.
Well, agree. But what's the definition of rhombus?
Oh, okay. We're going by the definition.
Yeah.
All right.
So rhombus is 4 congruent sides. This has 4 congruent sides. The differentiation between rhombus and square has got 4 right angles. Okay. Well, you know the pattern now. What are we going to say it is?
Theorem 5, 6.
It's parallelogram. So we get those 5 things: opposite sides are parallel, opposite
Why
angles.
would all squares be parallel by 4, and on the first one it's
Because this one already gives us that opposite sides are congruent.
Wait.
So 5, 6 is opposite angles. So I could have said it. Right? I don't know if I took this from the book or I just made that up. Yeah.
I
Ben.
thought isn't a square a rectangle?
Square is a rectangle, but not all
And
rectangles are true.
But your definition of a square right now.
We
Is
remember
that
we defined a rectangle first, and then we defined a square. So if I had done it the other way around, you were right. I would not be able to use that definition. If the first shape I
Yeah.
showed you was a square, I would not be able to say a rectangle because you got to prove it one piece at a time. All right. So we got rectangle, rhombi, rhombus, square. Those are the there's one more. It gets a whole section all to itself tomorrow or Monday. But these are the 3 that we're doing. We get 6 theorems from these 3 shapes. It's not like it's 2 per, but we get 6 theorems. So the rest of the class, we just run right through the theorems.
Right.
You're also going to see the first, I call it the table of death for homework tonight. It's a big honking table. I mean, like, it's huge.
What's number 32?
No, it's 1 through 10, if I remember right.
Oh,
You'll
okay.
see it. It's big, right? Okay, so what's this all about? Well, rectangles, squares, and rhombi, they're all parallelograms. So you can say these 5 things about any one of these and parallelograms. Okay, that's not too bad, but we get more, right? I don't know if it'll be confusing to you, but it's confusing to a lot of people when I give you 6 more things to say. I already got 5, so you're gonna have 11 things to say about these things.
Oh.
All right, so the first one, you're going to prove it tonight for homework. And that is, and my suggestion is pull triangles apart so you can visually see them better to prove it. It's theorem 5.2, and it says this, that the diagonals, well, it's parallelogram, so we know they bisect each other, but they're going to claim for a rectangle that the diagonals are congruent. So yesterday, Jack and I went into the discussion of could you prove for a parallelogram something about bisecting. We weren't able to prove it for a parallelogram, but for a rectangle, we can now prove, or you'll prove it tonight, right? That the diagonals are congruent. This is only true for rectangle, not true for parallelograms, unless the parallelogram is a rectangle. Secondly, whether the shape is a rectangle. Whether the shape is a rectangle. So this is true, theorem 5.12, for both rectangles and squares. So if you got a square, the diagonals are congruent. You got a rectangle, the diagonals are congruent. You got a parallelogram, you cannot say, if it's just a parallelogram, not a square rectangle, you can't say the diagonals are congruent. You can say they bisect each other. These bisect each other as well, but they are also congruent. And it's pretty simple to prove. 3 steps maybe, tops 4, 3 or 4.
Yeah, well, I mean, you just got to prove it by what?
Split the triangles, show the triangles congruent, call it CPCTC, and you're done.
No, SAS.
Good?
Yes.
All right, 1 of 6. All right, we will prove this one. So we got a rhombus, and we're going to prove that the diagonals are perpendicular. Now, if you were paying attention yesterday, we proved it the same way. So, I mean, if you had not seen me do it yesterday, when you're faced with a problem like this, you kind of don't know. There's lots of triangles here. You kind of just don't know which triangle to mess with. So usually, sometimes, don't be afraid to just mess around with a triangle, see if you can prove it's congruent.
Well, you don't need to mess around with because we have theorem.
The key here is let's talk about this triangle, and let's talk about this triangle.
No, why don't you do that?
Okay, the diagonals bisect each other.
The SSS for all of the triangles.
Well, then aren't we dealing with triangles?
Well, yeah, but you don't have to deal with the triangles at the time. You can deal with all of them at the same time.
Okay, so where does that get us?
Then it gets you to all angles are congruent, and then the consequence of that.
Wait. It gets us to all the angles are congruent?
All of the interior angles that have.
They're not all congruent to each other.
Yeah, they are.
Right. Well, that's what we're trying to find out. So if you go with the diagonals bisect each other, well, I got to use different tick marks. So that would be congruent to that. Then I got to put 3. 1, 2, 3 is congruent to that. Okay, that's
But
true.
all of the triangles have 1, 2, 3. So then they're all congruent.
So they're all congruent to each other. Therefore,
All of the interior angles are congruent.
okay,
Then you get that they're perpendicular because of the 90. Because they have to be 90.
why?
Because they add up to 360.
Oh, okay. Why can you say that?
Because 4 angles out of 360.
How do you know that?
I don't know.
Have we ever actually proven that?
Yeah.
Yeah, no, 4 minus
When?
2 times 180.
I don't know.
We proved that the internal angles of a polygon, we have 4 minus 2 times 180. But have we proven that this would be 360?
Wait, 4
But you use the
adjacent
sum
angles.
of interior anchors. Wait, you use that.
Wait, do you know that 4 adjacent angles are they all add up to 180?
Do we? I guess do we?
Yeah.
When did we ever prove that?
It's obvious though. Wait, but then you're not able to prove this.
You
Oh, no, we are.
It's the sum of
That's not
interior
true.
angles.
I mean, we're going to use part of what you just said. So how about we use this? Erase this. And I'm just going to go with this triangle and this triangle. Are they congruent?
Yeah.
Why?
SSS.
Right, because reflexive, right? Bisect. Now I'm going to erase this and say, look at this angle right here. What do we got?
Perpendicular.
Right?
But
Why
you
is it
can't-
perpendicular? Because it's something we have proven, which is that if you have 2 adjacent angles that form a and they are congruent. Therefore, the only way that happens if they're 90. We have proven that. We can use that. Okay. All right. I'm not debating that there's not 360 degrees in a circle. We haven't got that yet. All right. So that proof is basically what we just said. So call reflexive, call bisector, right? Call is a SSS, and then CPCTC. And then since those two angles make a line, I've used this word before. I called it a linear pair. A pair of angles that form a line add up to 180. And since this angle, right, this one right here is congruent to that one, then it's got to be 90 apiece. Okay. UED. What do we just prove?
Something. I love that spells.
Oh,
Yeah.
that,
Spells
the
dad.
diagonals
No.
of the rhombus are perpendicular.
Yes, so Allie got us back on track. We were messing around. All right, thank you. So the diagonals of a rhombus are perpendicular. Oh, guess what else is a rhombus?
It's a triangle. I mean, not triangle. Square.
So this is true for both rhombi and squares.
But what if I don't like squares?
By the way, this is not true for just plain old parallelograms. By the way, this is not true for rectangles, unless the rectangle is a square. This can become confusing. This is why they make you make this huge honking table. And then you have all the information in one table. And I typically say to kids, put that table in your book of truth, and you got all the information you need to know about quadrilaterals.
But what if you get all the table information wrong?
That's why I'm not going to tell you to put it in your book of truth until after Monday when we go over homework.
Oh,
Good? What is this, number 2 of 6?
you get 2.
All right,
We're almost.
4 more to go. What do you say when someone hiccups?
Bless you.
Gesundheit?
Gesundheit means,
Bless you.
Bless you, my child.
that's German for be healthy.
Gesundheit.
Gesund is the word health, and anything with EIT is an LY, so be healthy. All right, here's the next one, 514. Obviously, this looks like a
Triangle. No, square.
looks like a rhombus. And it says that, well, this is the thing that we tried to prove yesterday, Jack and I. We weren't able to prove it. So this one is claiming that the diagonals bisect their angles. And you'll have this tonight for homework, or weekend, or whatever you want. Remember, homework's due Monday.
Oh, yeah, I don't have to do it tonight.
But you do have next period.
Oh, yeah, that, okay.
And you're going to have a guest teacher.
Oh, yeah, you.
I just want to go there so I can look at the construction.
Oh, really?
It's very loud and
They're tearing lots of stuff down today.
Well, they chose the wrong time. It's supposed to be freezing tomorrow.
It's supposed to snow on Sunday and maybe Monday. This is the last time I checked.
I don't want to wear
So I'm
pants.
keeping my
You don't
fingers
have to.
crossed for snow day.
Just smart. Yeah. Just smart.
Well, could we at least wear some sweatpants? I don't get why we have to wear those
Yeah,
hard.
they're calling for snow Sunday, Monday.
On Tuesday, you can wear something.
Oh,
We
yeah, I
can
know
wear
what
some
I'm
technically
saying.
you can on
Mhm.
Monday.
Oh, when do we do
One of
those?
the teachers wears them.
I don't know that.
Mr. C, have you ever wear sweatpants to work?
Never. Oh, in the Army, yeah, sure.
Oh, okay.
Yeah, but he wasn't a teacher at that point.
Well, he
Never as a teacher, no.
but he still is one of our teachers. So by
My old school would have
reflexive-
pajama day, and I wouldn't wear pajamas. Teachers would wear pajamas. I was like, what?
Wait, do we use that for circles?
No, it's going to be for, there's a one on right triangles, and you're going to see trigonometry. I think it's chapter 8, I believe.
Oh, yeah, 8.5, 8.7, 8.6.
Okay.
The tangent ratio, the sine and cosine ratio.
If you did not already realize what bisect means, that means that these diagonals bisect angle D, they bisect angle C, so forth, so on.
Yeah.
All right. And remember, rhombi are also squares, right? I'm saying squares are also rhombi. So it's true for squares as well too, that the diagonals bisect the corners. All right, switching gears here. I'm going to give you a talking proof. Talking proof is we just basically talk through it. I don't write a formal thing, we just talk about it. So I'm going to make you make a right triangle, right? I don't say anything special about it, not an isosceles right triangle, just a right triangle. Okay, so there's a right triangle. I'm not claiming anything about distances.
You can use HL for this.
X plus BX equals CX.
Yeah.
No, X squared, A squared plus B squared equals
No, I have no idea what somebody wrote that up there, but
Wait, X and Z
it's not about
together,
this.
together equal 180.
All right, here's what I want you to do. We're going to turn this into a quadrilateral. So what we need is we need two more sides, right? So I'm going to make you connect X over to a point which I will call K, and I want you to make XK the same length as ZY. Okay? And then I want you to connect K to Y, but I want you to make it the same length as XZ.
So then you get a rectangle with a bisector.
So that's what I'm trying to do that right there. So the question is, what did I just make?
A rectangle with a bisector.
Well, how do you know it's a rectangle?
Because there's one right angle.
Well, why did I make a parallelogram?
Because the two sides were the same.
So in other words,
Opposite sides.
opposite sides are congruent, therefore I made a parallelogram. Why did I make a rectangle?
Because you have one right angle and all the interior, well, they have to.
Yeah,
Because of
they're
opposite angles and then supplementary and then
Okay,
supplementary.
but it has to start with what she said. It can't be just opposite angles congruent. That's only true if it's a parallelogram. But we prove it's a parallelogram first, and then we do the, I mean, there's lots of different ways of doing it, but that'll work. Opposite angles of a parallelogram are congruent, and then consecutive angles are supplementary. Okay, so yeah, we made a rectangle. Okay, great. So what? All right. Now what I'm going to do is I'm going to make one more construction. I'm going to connect Z to K.
Then you can use theorem
Now
515.
suspiciously, I put an M there.
The midpoint of both of them.
Yeah, that's what it does.
They join.
What's the shape I made?
A rhombus or a
A
rectangle.
rectangle.
What do we know about the diagonals of rectangles?
They bisect.
Well, that's for parallelogram.
Well, they are rectangles, not parallelograms. I mean,
And we know because it's a rectangle that they are.
congruent.
So that means that this is the same as this, is the same as this, is the same as this. You see what I did?
Yes.
Now what I'm going to do is I'm going to take my magic eraser and I'm going to erase. Oh, that didn't work. I better click the button. I'm going to erase the top part.
Oh, no.
See what I did?
Yeah.
So what kind of triangle is this?
Nice sausage.
No, I said
Oh,
it's a right triangle. Where did I draw this line?
At the bisect, no, not bisecting Z.
Where did I draw this line?
At the midpoint of M to C
And what was Z?
was the angle of a parallel
Okay, I went from the right angle to the
hypotenuse. So you just
To
made
the-
So you made a median opposite.
to the you know like where she's going
To
with
the
this.
midpoint.
To the midpoint of the hypotenuse.
So you just
Okay.
made a median.
I did make one, but I'm saying it goes from the right angle to the midpoint of the hypotenuse because that's the way the proof's going to, or the theorem's going to talk about.
Hey.
But when you do that construction for any right triangle, guess what happens?
You get two.
I don't get two congruent parts.
You
3.
get 3.
I get three congruent parts. Now it doesn't seem like it would ever be useful. It ends up being useful later in the book. But check what happens. If you draw a if you draw a segment from the right angle of a right triangle to the midpoint of its hypotenuse, you make three congruent parts. That's theorem whatever we're on. Right? 515.
Outside.
The verbiage is not, that's why I do the proof there, just so you have a good visual explanation of what it is. It says, a line from the right angle of a right triangle to the midpoint of its hypotenuse is congruent to the two parts of the hypotenuse. It just doesn't flow well with me. I mean, it's true. I would rather it says creates three congruent segments. Now, it's a bit more descriptive because it tells you where those congruent segments are.
Why we're not doing Saxon? We have hundreds of problems.
I don't think I've ever seen a Saxon geometry book. There may exist, but I've never seen one.
The only time I've done Saxon, it's a lot.
Oh, I
They
didn't
make
do
it
it for
sound
6
fun.
years. So glad to be rid of that gigantic yellow book.
What number are we on? Is this 4?
Probably.
Okay, we got 2 left. 2 left. 10 minutes and 2 left. 2 left. We can do this.
I missed the one.
And I'm not proving I don't think either one of them, so we'll be done easily. All right.
What's the history of a triangle? Did a caveman just draw one? Yeah, probably.
No, I assume it was probably the Greeks.
But the triangles did exist before the Greeks.
Triangles always existed. I mean, math exists without man or humans, right? The fact that 1 + 1 is 2 doesn't require humans.
Yeah.
But we're the ones who come up with it.
Well, we're the
Yeah,
ones that came up with the
requires-
symbols for it, but we didn't come
requires
up.
humans to figure out that that was
We didn't have to. There's an argument: is math discovered or is math invented? And I mean, math is typically discovered, not invented. I mean, it exists. It's like saying, Columbus discovered, the North American continent. Although that obviously is not true. We believe it was Leif Erikson, but anyway, and even that's arguing because he was actually Greenlandish, although they do claim an island or two off Canada. All right. Next one's pretty easy. We've actually proven this before. We proved it yesterday. We just didn't pay attention to it. If you have a quadrilateral with one right angle, guess what you actually have, right? Yeah, you got a, and I'm sorry, parallelogram, not quadrilateral. It's got to be a parallel. It can't be because you can have a trapezoid.
Yeah, you can have a trapezoid. Right?
So it's got to be a parallelogram. So a parallelogram with one right angle is always. It's always a rectangle. And we proved this a couple proofs ago, right? So if it's a parallelogram, then opposite and consecutive angles.
I thought it was going to be geometry.
No, he's not. Algebra 1.
I thought he was already in algebra.
He's in pre-algebra.
Oh.
So then Ryan's in algebra 1.
Ryan, there's 3 of them. Ryan and 2 that I don't.
Wait, why are the other 9th grade in algebra 1 right now?
Because that's normal for 9th graders. Algebra 1 is a 9th grade course.
Oh. What's a 7th grade course? If we did pre-algebra. Right?
Pre-algebra,
Course 1.
Course 1. Oh, okay.
which you didn't take.
Is,
If we had a more homogeneous mix of kids, some of you probably would have taken algebra or course 1. But since we had more kids that were advanced than weren't advanced, we said, well, we couldn't split up because of the fire code thing. And we couldn't split it up into a class of 2 or 5 or something like that in a class of 26. So we erred on the side of, well, let's just teach them at a higher level, and the ones that will stay with us will stay with us. The ones that won't, and then we'll help them out. It worked out. You guys all made it through. Okay. Last one. 517. What's the shape?
Triangle.
It's actually just a quadrilateral,
okay, but it's also a rhombus.
right? So if you have a parallelogram, now I'm saying it's parallelogram, not just a quadrilateral. If you have parallelogram with 2 congruent sides, then what?
Then it's a rhombus
Why?
because of opposite sides.
Because opposite sides are congruent. Doesn't work if it's just a quadrilateral, because you could have a trapezoid like this as well too, and trapezoid is not a rhombus. I shouldn't even talk about trapezoids because I haven't defined what that is. That'll be Monday's class, because trapezoids are special. You get a whole section to themselves.
Why does every single shape have to be special? Why can't we just put them
I know.
all in one and say this is what it is?
I assume the specialist shape is a triangle.
No, I would say circle.
Now, you can make an argument for that. For polygons, circle is pretty darn special. Agreed.
Oh yeah.
But why is the circle so special? Because all it does is equal up.
Take
to
the
3.1.
circumference of any circle divided by its diameter, and you get pi every time. That's why it's special.
But that's just a formula. I don't get it.
No, but I'm saying you get this special number 3.14, and that's like, it doesn't matter if you take any circle, and divide its circumference by its diameter, you get this number. Even today, that causes people to question
Even
things.
the biggest circle, like if I did the Earth, that would.
Earth is close to a person. It's not a perfect circle, but it's close. Right? We call it I've already forgotten.
Well,
we call it something oblated spheroid. Is that the
Oh
word?
yeah, because the Earth is.
It's
no.
slightly squished. It's not oblated. What is it called? I'll look it up. All right. Okay, so that was 6 theorems. That was a lot. So for homework tonight, they're going to give you shapes. They're going to say what you get. Oh, by the way, there's our kite that they don't even talk about. Apparently, kites are really not special because they never talk about them. I don't know. I like kites.
So that, wait, that would mean that consecutive sides.
No.
2 consecutive sides are congruent, but they don't
Yeah.
specifically say which ones.
Ooh,
And we
circle.
would say 2 pairs of consecutive sides
Yeah, those two, but it's not parallel.
is not a parallelogram, right? All right. So they're going to give you some shapes. Go if you haven't ever opened up your book, take a look at that.
It's a trapezoid. Okay.
Take a look at that table of pain, because it's a lot.
Oh, that's not so bad. Look, see, opposite sides of parallel. That's true. Not really. That might be wrong.
You see how big that sucker is?
Yes.
So that's going to tell you everything you need to know about every quadrilateral except trapezoids.
That's 187.
Whoa, computer can't. Well, you calculate the length of side diagonal. Ooh.
You could type that into your calculator, except you have to change it from basic to a TI basic.
Yeah.
All right, pick a line. Yeah. Let's do line 4. So it says all diagonals form 2 congruent triangles.
Just a diagonal.
Oh, a diagonal. I said all. A diagonal forms 2 congruent triangles. What?
That's true for
all of them.
Yeah, all of them. Yeah.
Well, you got to prove that one to me. So we're starting with a parallelogram, right? And what does it say? A diagonal?
Yeah.
So a diagonal, okay, the first one is a rectangle. So a diagonal forms what? Is that true?
Yes.
Why?
Because the parallelogram, the top 2 sides are congruent, the other 2 sides are congruent, and the reflexive means that's the S.
All right.
Yeah.
Now what?
Now rhombus.
Okay, so rhombus would be the only one that we might consider maybe not, right?
No, it would because of the same.
No, I know that, but I'm saying the one that might cause you, I don't know, some logical problem. So if I draw that one,
They're congruent
why?
because of reflexive and because of the opposite
Right.
side congruent.
Opposite sides congruent and reflexive. Okay, and well, we don't need to do a square.
Exactly the same one.
Okay.
As long as it's a parallelogram, squares.
So that one wasn't too bad. So they just want you to put like an x squared if it's yes or no. That's all.
And also all true. Well, except the parallel.
What does 10 say?
All sides are congruent.
Except the parallel.
No, that's just rhombus.
Except-
That's rhombus and square.
That's rhombus squared.
Yes.
So when they say parallelogram, they're not saying like, well, wait a minute, a square is a parallelogram. They're just saying that classical shape of a parallelogram that isn't a square, isn't a rectangle, isn't a rhombus. All right, let's take a look at this one. This one requires a little bit of thought. Number 7, it says that this whole thing's a rhombus, and it says F being equidistant from E to G. Why is that true?
Because it's an isosceles triangle.
What does that got to do with anything?
Because it's equidistant.
A couple ways you can explain this. One, it's a rhombus, so all sides are the same.
Yeah.
Therefore, those tick marks must be. The other way you could say why is it equidistant is that one theorem that said that if you have a segment
Yeah, and
and
then
a
point on the
perpendicular,
bisector.
any point is equidistant to the
On the
corners.
perpendicular bisector.
And it is a perpendicular bisector, by the way. Yeah. Okay. So being equidistant must lie on the perpendicular bisector of EG. There you go. H being equidistant from EG must lie on the, they're getting kind of lazy here. All right, that's the same answer. From A to B, they're talking about this A and B. So from A to B, you can deduce that FH is the
Perpendicular bisector of each.
And good luck stating that because I can't remember what it is.
State the theorem of this. Okay, I got it.
I don't know. It's last chapter, right?
16. Theorem 16.
It's got to have a 4 in it because we're in
Oh,
chapter
Theorem
5.
416.
No, we didn't have a 416.
Well, maybe we did. We just didn't realize it. Think of that.
Oh, theorem 4.6.
All right.
Yes.
I was close. Very close. 16 is only 10
10
away.
Right. All right. These are cool. This is crazy cool. Right. We'll talk about that here in a second. So let's see. Angle KAP is a right angle. And AM is a median. If MP is 6.5, then MP, sorry. If MP is 6.5, how big is MA?
Oh, and 6.5.
Yeah, because remember this piece, and this piece. If it's a right triangle, you go from the right angle to the midpoint of the hypotenuse. They're all congruent. If MA is 1, then KP is
2.
That's
T.
a T.
2 T.
where?
So
It
it's
says
not-
if
so it's
MA
T.
equals T.
Really?
So it's,
Yeah.
Oh,
yeah,
then it's
so it's 2T.
so it's 2T. And McKinley was right when I said 1. He said it was 2. Angle K is 40. Then KAM. Oh, that might be more interesting. So if angle K is 40, we're trying to figure out
You have to divide 40 to
That
get
one.
A. You have to divide 40 from A2 to get the angle at measurement from A to F.
It's 40
why.
because it's an isosceles.
Ooh, we know that this piece is equal to this piece,
Oh,
therefore
yeah.
it's 40. Very good. It's like every time that there's an answer, it's always something to do with an isosceles triangle. Now this is crazy. Some geometry teachers will have you do this. I think it's just interesting to point out. So what they're saying is if you take these polygons and you find the midpoint
Join all of them in line.
and you join them, what do you get each time?
Very low.
Isn't that crazy? That just bothers me. Notice these are just quadrilaterals. There's nothing special about them. It turns out that they're all parallelograms. That's nuts. I'm not sure how that's useful, other than it's an interesting fact. But it is pretty cool. And surprising at that. And in this one, we got a rectangle. By the way, what's this shape right here?
And the last one we can kite. No, it's not a kite.
No, it's it looks like an airplane, right?
Like a jet fighter.
Right.
It's like a paper.
It's actually a quadrilateral.
Yeah, I mean.
We would call this a concave quadrilateral.
Oh, yeah,
Right.
because then you can't.
All of these are convex quadrilaterals. This is a concave quadrilateral. Clearly an irregular quadrilateral. So the question is, if you make a regular quadrilateral, what would be the shape? The inside. You made a regular quadrilateral. What's the only regular quadrilateral we have?
Is a square.
So if you did this construction on a regular quadrilateral, what would the red be?
Just the
A
regular.
square.
So she's thinking it's going to be a square. So if you did a square and you found the midpoint of each,
They're gonna get a square.
our belief is
It's
you
the
get a
side
square.
with square.
Or rhombus. And you get a rhombus.
Now, the more interesting idea is we can't do this yet because we haven't talked about areas. What's the relationship between the area of the inside one and the outside one?
They're just slightly different. No,
That's an interesting thing. We will discuss this, just not this chapter.
All you have to do is divide by 2 and the thing.
You think it's half?
No, that wouldn't be right. Because
Well, we could use that and figure this out. But we haven't had this yet in geometry. But if we knew that, any one of the sides, it doesn't really matter, we could call it a side A. We could calculate this. If the side is, I don't know, 10, well, then we know that this side is 5, this side is 5, and we could use Pythagorean theorem to figure this. We could actually find the area is pretty simple.
But that has to be over a right triangle.
Where do you see a triangle?
Triangle.
Oh, yeah, it's absolutely a right triangle, right? Because remember, it's a square, so all the corners are right angles.
Yeah.
But since we don't have the Pythagorean theorem yet, we won't.
Or I could show the triangle.
Could we do that? Well, let's see. Well, we could draw that.
Well, I mean, you could do
because we're trying to prove the hypotenuse. If in fact it is a square, so if I made a line that's parallel to this one, right, then that's certainly 90 degrees. I'm sorry, that's 90 degrees right here. Yeah, we would have to investigate that.
You could prove that the top and bottom are.
How would we do that?
Because if it's a square on the side, then the
Well, that's the part we don't
We
know.
don't know it's
Yeah.
a square.
But we certainly could find out.
Well, we know it's a parallelogram.
I'm pretty sure that we could figure out that these three triangles are congruent.
Wait, do we know that's a parallelogram though?
We don't know that yet either. There's a lot of, you're going to learn chapter, I want to say 10 or 11. There's this thing called a coordinate proof, where we basically take this shape, we place it on the Cartesian coordinate plane, and therefore we can put numbers to
you
things
can
and
prove
figure.
that it's a square. I think.
Okay,
So you can say that the lines are all congruent, the outside ones, because of midpoint, definition of midpoint.
so
then you.
so those are congruent.
Oh wait, no, you can't. Oh yeah, and then all the angles are 90, so you can say SAS, and then you can say that all the inside lines of.
So we at least prove it's a rhombus,
Yeah.
right? So the question is it a square? It turns out it is, but we would have to do some more thinking on that one.
Because then you can prove that the top and bottom triangle inside the.
That's kind of how I would go at it, right? So if we prove the top and bottom, we
Yeah,
prove
but
that
then you
that's
just-
congruent to that.
Yeah.
Is that true? Well, clearly, we've got a reflexive. Oh, we can.
Yeah.
SSS, right?
Yeah. But
All
then
right.
we don't technically know that a square is 360 degrees. So all we can get from that is that it's parallelogram, right?
Well, how are we going to get that it's parallelogram? Or did we just prove it's rhombus? So if we prove it's a rhombus, we did. So it's parallelogram. So then we have opposite
You
angles are
can't say
congruent.
that. Yeah, you can say that all of them are 90 because it's the. Oh wait, you don't know the top and bottom.
Yeah, you just know that.
But we can say
We
that
could just do that and then similarity.
congruent, congruent.
And
Well,
then
yeah,
there's
because then if you do
supplement-
that, then it's similarity, and then n minus 2 times 360, and then they're all congruent. and
Well,
then
once again, n
minus 2 times
oh,
380, they're all
okay, yeah.
congruent.
So 360. Yeah, but we never proved that this was congruent to that.
Oh, yeah.
They're supplementary for sure, right? This one and this one, but we haven't proved that they're congruent. So I'll just say this begs for doing a coordinate proof. Maybe we'll. I forget. We actually do this at some point during the year, but that's an interesting construction. Okay, that's it. Ben, you have any questions?
Nope, none. I'll submit the test to you.
Okay, cool.
Wow, that was fun.
Goodbye. Have a nice day.
You as well.